We'll look at the first method you can use to work out your MPP when we are inside the cocked hat, and that will occur when the bearings between the bodies exceed 180 degrees. So here's an example question. We're given our course and speed and our DR position at 1823, and we observe the 3 stars. Now you can see first of all that the time is not at 1823. Now the rule is that if you observe the star before 1823, you plot after the 1823 position, and we'll look at the values very shortly. So A and B are plotted after, and if you observe the star after the 1823 position, then you plot before. So there's our course of 288, and that's where we would plot the 3. Now we're given an azimuth, so you would need to convert that to a bearing. We're given zenith distances, so remember true tiny towards with a zenith distance. But the first thing we need to do is calculate the distance for each observation from the DR. So 1812 to 23, 11 minutes, 2.6 miles. So we would go 2.6 miles further forward. Star B, 1.6 miles. Star C, 0.7 behind. And then we get the difference between, as I say, the zenith distances, and therefore we've now got our bearings and our distances to plot. And remember, it's inside the cocked hat. So that's the plot, and that one is bearing the position line for A. So 042 degrees 7.7 away, 282 9.2 away for B, and C 159 at 6.3 towards. Now you'll notice I've put A, B and C. So we're going to put where they cross, we're going to call that C and that C, A and A, B and B. So that means that we've got A and C, so we add the bearings of A and C together and divide by 2. We do the same for C and B and A and B. Therefore, from A and C, we draw a bearing of 100 degrees. C and B 220, C and B 220, and A and B 162, and where they all intersect, that will be the position of our vessel. So that's all we do. We get the two together, divide by 2. Now if we want the systematic error, then we simply, from the center, we would draw a circle that cuts all the sides, and that value taken to the range will give us our systematic error. So this is one way of finding the position of the vessel, most probable position, and of course the systematic error. So remember A, so both those are named A, line B, both named B, line C, both named C, and that's where we can get our values, add together and divide by 2.